If you guys can hear me, please type in yes in the chat window for the confirmation, please. Thank you, folks. In yesterday's demo session, I guess most of you attended yesterday's demo session. We discussed about the roadmap of this course, BW 7.4 with Service Pack 5 with SAP HANA 1.0 Service Pack 8. So in this course, we are learning complete SAP BW 7.4 with HANA as a underlying database. So whenever we are learning SAP BW with HANA as an underlying database, in this course, first we have to start learning with SAP HANA. The HANA concept, up to what extent we require for BW 7.4 with SAP HANA. So if you look at the course content of this course, the course content is divided into 3 main units. Unit 1, SAP HANA. Unit 2, SAP BW 7.4. And Unit 3, all the new enhancements of BW 7.3 with Service Pack 5 to BW 7.4 with Service Pack 5, HANA as an underlying database. So the part 1 is the HANA. We learn the complete HANA concepts up to what extent we require, okay, to learn BW as a HANA as an underlying database, like introduction to SAP HANA, SAP HANA business strategy, okay, SAP HANA architecture, SAP HANA Studio, SAP HANA complete modeling, data provisioning. Part 2 is BW. We'll start with BW. So modeling in BW, in depth of modeling BW, then extracting the data from different source systems, SAP ECC, SAP CRM to BW, then reporting using BEX reporting tools and SAP BOBA 4.0 and 4.1 integration. Then part 3 is complete new concepts of BW 7.3 from Service Pack 5 to BW 7.4 with HANA as the underlying database. And these are the projects we are going to cover as a part of this course. So today's our class agenda is the first in part 1, introduction to SAP HANA. So this is our class agenda today. Session 1, introduction to SAP HANA. So what exactly introduction to SAP HANA? In introduction to SAP HANA, we will cover what is the necessity of a high performance analytical appliance, okay, to an enterprise. And what is the history of SAP HANA, a brief history about SAP HANA, the product strategy of SAP HANA, and what are the editions in which HANA is available, what are the new software technology innovations and new hardware technology innovations that HANA can fully leverage, which makes HANA super duper fast. And okay, who are the certified vendors for SAP HANA appliance? What are the sizes in which HANA appliance is available? A brief introduction to SAP HANA. This is our class agenda today. Okay, SAP HANA. HANA stands for High Performance Analytical Appliance. It's a appliance. So what exactly is this appliance? Okay, what are the main components in appliance? Today we'll see what are the different components that comes along with this appliance, all the basics, okay, part of SAP HANA. It's nothing but a brief introduction to SAP HANA. So SAP HANA is a technology which allows the processing of huge quantity of real-time data in the main memory of the server to provide near-time results from the transactions. Now we'll understand this definition later on once we understand what exactly is SAP HANA, how it can process huge quantity of real-time data in the main memory of the server. So what is in-memory databases? So let's understand all these basic concepts, then we can easily understand this definition. Don't worry about this definition. In yesterday's demo session, we focused on what are the challenges, what are the consequences at this point of time the enterprises are facing as a result of information explosion. So what is the information explosion? As a result of globalization, when the enterprises started operations in different states within the country, in different countries, okay, in different continents, then the enterprise data spread across different geographical locations in different systems in different formats. If you look at this slide, in this slide, there are different systems where the data, business data resides in different formats. If you look at this data warehousing application, in the data warehousing application, the data will be stored in the form of info cubes, DSOs. If you look at this transactional system, the data will be stored in form of tables. If you look at this flat file system, the data will be stored in some other format. Whenever in enterprise, as a result of globalization and as a result of this information explosion, the data spread across different geographical locations in different systems and different formats. If this is a scenario in current day in enterprise, what are the challenges as a result of this information explosion? What are the consequences the enterprises are facing at this point of time? Well, challenges related to complex system landscape. So what is a system landscape? What are the different systems in an enterprise we have? Okay, all those systems comes under the system landscape of the client or the system landscape of the enterprise. So if this is a scenario, the system landscape is very complex. Whenever we have such a complex system landscape, then getting the data for reporting, very difficult. Getting the immediate results for business users. So the business users require immediate information, analysis, reports for decision making, and massive growth of data volume. Managing, whenever we have a very high volume of data, the first main challenge is execution speed. Suppose if I am using traditional databases, traditional tools to manage such a high volume of data, and I am executing a query on top of such a high volume of data, it's taking long time to execute the query. The users who are waiting for the response of the query, they will get frustrated. And lack of responsiveness, unsupportable business process. So we don't have, okay, in such a complex system landscape, streamlining everything, every business process is very difficult unless until you need to have a high performance appliance, a big data management tool to manage such a high volume of data. Lack of transparency. When we don't have much transparency in a complex system landscape, so again there are so many other problems faced by business users or problems faced by an enterprise. Need for aggregation, outdated figures, guessing current situation, reactive business model. So if you don't have a reactive business model, what is reactive business model? Okay, we need to have a business intelligence model so that based on that we can take spontaneous decision. If you are not able to take decisions on time, our competitors will take away our opportunities. It's very difficult to sustain in the market. So missing opportunities, competitive disadvantages. And on the other hand, the business users also require reports on real-time data. See, expectation to make the decisions in real-time data at the moment of risk and opportunity. So we discussed this one in the demo session also. One more time, just a brief recap. In any enterprise, this is an enterprise. In this enterprise, there are different business users. So who are the business users? The business users who are responsible for the decision making. Starting from CEOs, managing directors, major stakeholders, department heads, finance manager, sales managers, marketing manager, you name any business people in the business, the key business people in the business who are responsible for decision making. How they are going to make the decisions? Are they going to make the decisions blindly? No. No manager, no business user can make the decisions blindly. In order to make effective decisions, they require proper reports and proper analysis. Unless until these reports and analysis are not ready, the business users are helpless. They cannot make any decisions just blindly. So these business users required reports and analysis on historical data. What is historical data? Suppose a company started 4 years back, or 10 years back, or 2 years back. So analyzing the complete historical data of the business to take some decisions. So what type of decisions we can take based on analysis of historical data? Decision related to forecasting, trend analysis, budgeting, planning. So all these type of decisions the business user can take based on historical data. By analyzing the historical data, the decisions related to forecasting. So I have given a couple of examples in yesterday demo session also. Forecasting, trend analysis, budgeting, planning. On the other hand, the business users also require reports on real-time data. What is real-time data? Real-time data, up-to-date data. Suppose this is a transactional system where the day-to-day business transactions are happening. A OLTP application, a transactional system. From this transactional application, once the data is saved, we need the data right away for the reporting. Means the reports on up-to-date data, the latest data, okay, including the data including up to last commit. No, I'm sharing my screen. Now everyone can see my screen. Vijay, can you see my screen? Mr. Vijay Kumar? Hello sir, can you see my screen? Yes, everyone can see my screen. So everyone can see my screen and everyone can hear my voice, right? Mr. Daniel, Dilesh, Mohammed, Omar, Ramya, Vijay Kumar. Yes. So no need to relog in. So I guess everyone, yeah, everyone can see my screen as well as they can hear my voice as well. So what is real-time data is reports on up-to-date data. Like whenever the business user has to make some spontaneous decisions. Okay, we require reports on real-time data, up-to-date data, like order status tracking reports, where we need the data up to last order which is saved in the database. Okay, delivery status tracking reports, inventory level monitoring reports. If you look at this complex system landscape, whenever we have such a complex system landscape, it's very difficult to get the real-time data for the real-time reports, because the business user, not only they require the reports on historical data, they also require the reports on real-time data. So getting the real-time data from such a complex landscape is very difficult, is a very challenging part. So whenever we are using traditional databases, traditional tools to manage such a high volume of data, it's very cost-effective management of large data volumes. Second, getting the current and complete information, current means real time, is very difficult, because if you look at traditional databases like Oracle, SQL Server, Teradata, in these databases we don't have mechanisms, okay, or methods given by these vendors to get the real-time data. And whenever we are executing a query on top of such a high volume of data using traditional databases, traditional tools, it's going to take a long time. So why the query execution process is going to take very long time whenever we are using traditional databases, traditional tools to manage such a high volume of data? First of all, we have to understand how a traditional database will work. What is a traditional analytics? What is a in-memory analytics? What is the difference between traditional and in-memory analytics? How in-memory analytics is very faster when comparing with traditional analytics. In traditional databases, my friends, you name any traditional database, the primary persistence of the data is hard drive. The complete data resides in the hard drive. So what is a hard drive? It's a mechanical device. Okay, this is the CPU. This is the main memory, RAM. So whenever we require the data for processing, for reporting, the CPU or the processor will perform disk IOs on hard drive, which is a mechanical device, to read the data from hard drive to RAM. So in order to perform disk IOs on a mechanical device like hard drive, it required significant amount of time, which are major bottlenecks in traditional analytics. See, what are the major bottlenecks in the traditional analytics? The disk IOs. Performance bottlenecks in the past, when we are using traditional databases, traditional tools to manage such a high volume of data, the major bottlenecks are disk IOs. That is the reason whenever we are executing a query using traditional databases, traditional tools on such a high volume of data, is going to take time. But in-memory database, this is traditional analytics. Traditional analytics using traditional databases. But in-memory database like SAP HANA, Greenplum, or in any in-memory database, the primary persistence of the data is RAM, not in hard drive. The complete data resides in the RAM itself. So we don't require any disk IOs to be performed. Okay, the data for the reporting. No, the data for the reporting directly available from main memory of the server. This is called in-memory analytics. So using traditional databases, traditional analytics is possible. Using in-memory databases, in-memory analytics is possible, because in any in-memory database, the primary persistence of the data is not hard drive. The complete data resides in the RAM itself. It doesn't matter. It's a terabytes of data, petabytes of data. So HANA can accommodate such a high volume of data in the main memory of the server. In-memory analytics. Now, whatever the challenges, consequences I was going through as a result of information explosion, we can overcome all those challenges, all those consequences by using SAP HANA as one of the solutions. How? Now we'll see what is the reality with SAP HANA. In SAP HANA, scalability is highly scalable because the complete data resides in the main memory, because SAP HANA is an in-memory database. It's not a traditional database. The complete data resides in the main memory. Groundbreaking in-memory innovations. It's very flexible. Extracting the data from any source system to SAP HANA is very flexible. That too, in SAP HANA, one of the biggest strengths of SAP HANA is SAP HANA supports real-time replication from SAP as well as non-SAP source systems. So what is one of the biggest challenge when we are using traditional databases? Most of the traditional databases does not support any real-time replication method. Replication method means, real-time replication method means, once the data is saved in the source system, I need the data right away in SAP HANA for the reporting, or whatever the database I am using for the reporting. So in SAP HANA, there are two real-time replication methods supported by HANA. Using those two real-time replication methods, from any source system, we can replicate the real-time data to SAP HANA. You can load the data from any source system, and it supports real-time access to transactional data. Very flexible, and speed-wise, 3,600 times faster when comparing with traditional databases, traditional analytics. The reason is, always in-memory analytics is very faster when comparing with traditional analytics. The reason is in traditional analytics, the complete data resides in the hard drive. So we require disk IOs to read the data from hard drive to RAM, okay, in order to get the data for the reporting. But whereas in SAP HANA or in any other in-memory database, we don't need any disk IOs to read the data from hard drive to RAM, because the complete data resides in RAM itself. In any in-memory database, the primary persistence of the data is main memory, RAM. From RAM, the data is directly available for the reporting. This is nothing but in-memory analytics. Apart from this in-memory capabilities, today we will see what are the new hardware technology innovations and new software technology innovations that HANA can fully leverage, which makes HANA super duper fast. So not only in-memory capabilities, there are so many other features which makes HANA super duper fast. That is the reason this is the speed of SAP HANA. Just to show you one POC result to understand what is the speed of SAP HANA. 70 retailers, they combined 50 terabytes of data and 460 billion records. A query is executed with complex calculations. In order to execute the query, it was taking before 77 minutes with traditional database. With SAP HANA, 13 seconds. See, this is terabytes of data, 50 terabytes. This POC is conducted with 50 terabytes of data. Recently, NASA conducted a POC with petabytes of data. What is 1 petabyte? 1024 terabytes equivalent to 1 petabyte. See here, only total data volume, this POC is pretty old POC, proof of concept project. So 50 terabytes. Now the latest POC conducted with petabytes of data. Again, the complex queries are tested and the results are coming back within seconds. Any questions, folks, up to this point of time? So we discussed what is information explosion. Okay, what are the challenges, consequences faced by an enterprise in current day scenario as a result of these information explosions? So whenever a company is using traditional databases, traditional tools to manage such a high volume of data, it's nothing but traditional analytics. So what are the drawbacks? What are the major bottlenecks related to performance, related to storage and all? Then what is in-memory database? Using SAP HANA, how we can overcome all these challenges and consequences faced by an enterprise. Now maybe you guys have so many questions in your mind, like what is the size of RAM it supports? We'll see all. Okay, what type of new hardware technology innovations, new software technology innovations it supports? What is the size of RAM you can accommodate in SAP HANA appliance and all? Now we'll see the history of SAP HANA. Now we have clear idea why SAP introduced SAP HANA. What is the purpose of a high performance analytical appliance or a big data tool in current day scenario? Because in current day scenario, this is a situation faced by most of the enterprises. These are the challenges and consequences they are facing at this point of time. In order to overcome these challenges and consequences, most of the enterprises which are dealing with high volume of data, they require a big data solution. Okay, SAP HANA high performance analytical appliance released by SAP in 2010 November. First version of HANA is, okay, which is the first public release, HANA 1.0 support pack 0. Now the current version of SAP HANA is HANA 1.0 Service Pack 8. This is a SAP HANA in-memory database, HANA appliance. So the current version is HANA 1.0 Service Pack 8. See, okay, this is a host name, database name, version is 1.0 Service Pack 8. This service pack released by SAP 2014 May 31st, 2 months back. So what is the first version of SAP HANA? The first public release of SAP HANA, the version is 1.0 Service Pack 0. Then SAP released Service Pack 1, Service Pack 2. Up to Service Pack 2, what is the product strategy of SAP HANA? What is product strategy in the sense, I am a client, I want to implement SAP HANA. How I can use this SAP HANA appliance? For which purpose I can use this appliance? So the purpose up to support pack 2, only one purpose product strategy supported by SAP HANA up to support pack 2. What is that product strategy is HANA as a data mart. HANA as a data mart. What is HANA as a data mart? HANA as a data mart is nothing but HANA as one of the solutions for the big data. So what is big data? Big data refers to the data sets that exceed the ability of commonly used databases, commonly used tools. While no formal definition based on size exists, these data sets typically reach terabytes, petabytes, or even exabytes in size. SAP has positioned HANA as one of the solutions for the big data at the low end of scale. Okay, nowadays, maybe you guys heard about the big data projects. There are so many jobs for the big data projects, big data. So next gender, okay, is going to be complete era of the new data. So current market for big data is 24 billion US dollars. It's not a small amount, 24 billion US dollars. That is the current market of big data. So what is a big data project is? The companies, okay, which are dealing with, the enterprises which are dealing with high volume of data, they will manage the big data using big data tools, big data technologies, not using traditional tools, traditional databases. That is nothing but a big data project. So the companies nowadays preferring to use the tools which are specifically designed, okay, the databases, the tools, the technologies which are available in the market to manage such a big data, to manage the big data, implementing those technologies, okay, using those tools to store the company's big data is nothing but a big data project. So in order to store the data, big data, there are different types of solutions are available in the market. Hadoop. Hadoop is a technology from Apache. It's an open source. Hadoop is an open source, and in Hadoop, the data is stored. Okay, that big data is stored in a cluster, Hadoop cluster. It's a cluster-based technology. It's a cluster-based solution for the big data. So what is a cluster? In a Hadoop cluster, what is Hadoop concept? First of all, it's very simple concept of Hadoop. Suppose if we are storing the data, the complete data in one system, basically we are overburdening the system. instead of storing the big data in one system, will distribute the data over several computers in the network. So in the network of computers, we have a main machine or master machine, so which controls a number of slave machines. So this is Hadoop cluster. So here, instead of storing the data in one machine, we'll store the data in different machines over the network, and all these slave nodes are controlled by a master machine. See, this is Hadoop cluster, my friends. In Hadoop, the data will be stored not in one machine. Distributed storage. This is called distributed storage concept. So Hadoop distributed file system. The data is stored in the file system, Hadoop distributed file system. The data will be stored in several computers, several machines, which are controlled by a master machine. So we will store the data in form of Hadoop distributed file system or several computers in the network, which is controlled by a master machine. In order to process the data, we'll use a programming language called MapReduce. So using Hadoop cluster, distributed processing possible, distributed storage is possible. So it's very faster. So instead of overburdening one machine by storing the complete data in one machine, we are distributing the data over the several machines in the network. Same. Suppose one person is completing a task. In order to complete a task, one person, it required 10 days. If I am allocating 10 persons to complete the task, 10 persons together can complete the task in one day. Which one is faster? Second one is faster. So if you look at this, one of the Hadoop cluster maintained by Yahoo to store their big data, a Hadoop cluster with 25,000 slave nodes, 25,000 machines in the network, controlled by a master machine. So the social media companies like Facebook, Yahoo, Twitter, they will generate very, very high volume of data. So they will manage such a Hadoop cluster, SAP HANA, to maintain their big data. Not only these companies, any companies who wants to implement the big data project. On the other hand, there is one more solution for the big data, that is SAP HANA. SAP HANA is an in-memory based solution. So what is in-memory based solution? The complete data resides in the main memory. In-memory analytics, very faster. And apart from that, Hadoop, the data is stored in the file system, whereas in SAP HANA, which is a in-memory database, the data is stored in the form of tables. So this is SAP HANA database. So the data will be stored in form of tables. These are the HANA schemas, database schemas, like how we have the concept of schema in any other database. Here also, this is the concept of schema. You can create a number of schemas. Again, in each schema, you can create thousands of tables. See, like in normal databases, so how we'll store the data in form of tables, relations. So when SAP released SAP HANA, up to support pack 2, HANA supports only one product strategy. So the initial product strategy of SAP HANA given by SAP is HANA as a data mart up to support pack 2. So SAP positioned HANA as one of the solutions for the big data. At launch, HANA started with 1 terabyte of RAM, supporting up to 5 terabytes of uncompressed data. In late 2011, hardware with 8 terabyte of RAM became available with support up to 40 terabytes of uncompressed data. One of the biggest advantages of SAP HANA is, in SAP HANA, whenever we are storing the data is highly compressed. In SAP HANA, there is a concept of column-based tables. Today we'll talk about what are the column-based tables, row-based tables. Suppose in traditional database, we have 1 terabyte of data. If we are loading the same data in SAP HANA database, one terabyte of data approximately will become 100 GB. This is called compressed data. Means if you have 10 terabytes of data, here 1 terabyte. In May 2012, SAP built an HANA appliance in collaboration with IBM with 100 terabytes of main memory. See, this is 2 years old statistics. 2 years old statistics. Main memory, okay, and Hasso Plattner, who is the project in charge for this project, claimed that this HANA appliance can accommodate 8 companies' data, 8 largest companies' data in one HANA appliance. Just imagine what is the capacity of SAP HANA, how much big data it can accommodate in the main memory itself. 8 companies' data in one HANA appliance, not one company data, 8 companies' data. So like this, in one company we have very complex system landscape. Like this, 8 companies' data. So whenever a client is using SAP HANA as one of the solutions for the big data, or HANA as a data mart. So in that project, what are the different stages we have? Whenever a client is using SAP HANA as a data mart, okay, in that project, we have 3 main stages. See, up to support pack to HANA as a data mart. What does it mean? Means HANA as one of the solutions for the big data. A client is dealing with big data. They have different source system. Very high volume of data is spread across different geographical locations in different systems and in different formats. So they need all the data in SAP HANA. They want to streamline all their big data. They want to implement a big data project using SAP HANA. So whenever a client is implementing SAP HANA for the solution of the big data, in that project there are 3 main stages. First one is loading the data from different source system to SAP HANA. Once we install the HANA appliance and all. Now, this is a system landscape of a company. They have the data in the spreadsheets. They have the data in data warehousing applications, OLTP applications, databases, mainframes, whatever it is, whatever the source system is. First stage is loading the data from different source systems to SAP HANA. So how we'll store the data in SAP HANA? In form of tables. As per our data storage requirements, we'll create the schemas. So we'll create the corresponding tables. First step is we'll load the data to SAP HANA. Okay. So why the business is storing all the big data in Hadoop or in SAP HANA? Eventually they require the reports. Eventually they require the reports and analysis for decision making process. So every business requires the reports on their historical data, on the real-time data for the decision making process. So what type of the business, what type of reports required for a business? Reports on historical data, reports on real-time data. Now we have to load the historical data from different source systems. as well as from which source system we require the real-time data, we have to set up the real-time replication method also. So in order to reach all the client requirements, client needs for the data loading, in SAP HANA it supports various data provisioning methods. What is data provisioning in SAP HANA is loading the data from different source system to SAP HANA is nothing but data provisioning. In other data warehousing technologies, so it's a data loading process. But in SAP HANA, SAP has given a proper terminology. What is the terminology is data provisioning is nothing but loading the data from different source system to SAP HANA. So what are the different data provisioning methods given by SAP? First one is directly loading the data from the flat files to SAP HANA. So if you look at this system landscape of the client, so some of the data resides in the file system, in spreadsheets, in CSV files. So loading the data from file system to HANA, flat file extractions. Second one is from a source system, the client wants to load the data to SAP HANA on a periodic basis, like on daily basis or on monthly basis and on weekly basis. And before loading the data, they need some complex transformations to be performed. The data in a source system is not in its original shape. Before loading the data to SAP HANA, they need complex transformations to be performed, and the client wants to load the data on a periodic basis, batch mode. What is periodic basis? What is batch mode loading method? On periodic basis, like on daily basis or on weekly basis or on monthly basis. Suppose the client required COPA reports monthly basis. For example, in that case we are going to load the data on monthly basis. The client required sales order reports for the scenario on daily basis. Then we are going to set the jobs as a batch jobs on daily basis. This is nothing but batch type of data loading. So whenever the client wants to load the data from a source system and the data is not in its original shape, before loading the data to SAP HANA, we need complex transformations to be performed, and from some source systems the client required batch, means they want to load the data on a periodic basis. In that case, we'll use ETL based approach. In ETL based approach, the certified ETL tool. What is ETL tool? Extract, transform and load. Like Informatica data stage, there is one SAP proprietary ETL tool. The name of the SAP proprietary ETL tool is Business Object Data Services. Bots. So bots is very powerful ETL tool like Informatica data stage, which supports various types of transforms and functions, scripts, scripting languages. By using all these options, we can massage the data, we can cleanse the data before loading the data to SAP HANA. That too, we can load the data on a periodic basis. We can set the jobs on periodic basis. That is ETL based approach. ETL based approach. Now, there are some source systems from which business required the data to be replicated in real-time mode. What is real-time mode? See, real-time. We require the reports on real-time data also. What is real-time data is, once the transaction is saved in the source system, we need the data right away in SAP HANA. Right away I need the data for the reporting. That's it. Real-time replication. For replicating the data in real-time mode into SAP HANA for the reporting purpose, SAP has given two real-time replication methods. One is SLT. SLT stands for SAP Landscape Transformation. Suppose now we configured SLT from a SAP source system, SAP ECC, or you can configure with PeopleSoft, any SAP or non-SAP, from a Java application, any application. So once the data is saved in this table in the source system, right away the data is, say, replication is in progress. Replication is in progress. That is nothing but trigger-based replication. SLT is also known as trigger-based replication. Second one is Sybase replication method, log-based replication. And apart from this, so these two are real-time replication methods. Apart from this, SAP has given direct extractor connection, smart data access, different data provisioning methods in order to achieve the different client needs. Okay. Once the data has been loaded or the data replication is going on in SAP HANA tables using different data provisioning methods. First one is data provisioning. When a client is using SAP HANA as one of the solution for the big data. So depends upon the client requirement, we'll go for any one of these data provisioning methods to load the data from different source system to SAP HANA by executing complex transformation in a batch mode using business update data services, which is an ETL tool. If client require real-time replication, we can use SLT, Sybase replication server, different data provisioning methods. Once the data has been loaded to HANA database table using different data provisioning methods as per the client needs. Second one is modeling. HANA modeling. HANA modeling is very important for BW consultants. That is the reason in this course we'll cover in depth of modeling, HANA modeling. Complete HANA modeling. Because we can consume HANA information models in SAP BW by creating composite providers and transient providers. We can import BW models in SAP HANA, then system will create corresponding HANA information models. As a BW consultant, you need to have complete understanding of BW, HANA modeling. So the second stage in the HANA as a data mart project is modeling. So what is modeling? Based on these tables, designing our information models to facilitate the reporting requirements. Now I have some tables here, but the business required multi-dimensional reports. Whenever we require a multi-dimensional reports, we'll design HANA InfoCube, analytical view, a star schema concept, attribute views, dimensions, analytical views, InfoCubes, HANA InfoCubes or HANA analytical views. See, fact tables surrounded by dimension tables, multi-dimensional modeling, calculation views, to combine the data from different analytical views from different information models in order to achieve the complex reporting requirements, like info sets, multi-providers in BW. So modeling itself is a very big concept. Anyways, we'll be covering the complete modeling concepts as a part of this course. So once the modeling is done, in order to perform all the modeling, we'll use a tool called SAP HANA Studio. So this is SAP HANA Studio, a client tool. This is a Java-based Eclipse tool. So we'll be covering in depth of this tool also before starting modeling classes. So this is a client tool using which we can add our HANA IMC. So HANA modeling perspective, we can design all information models. Now in the latest version of SAP HANA Studio, not only you can do HANA modeling, see we can do BW modeling also. Can you guys see here, last one, see BW modeling. So in order to create composite providers, transient providers, in order to consume HANA information models in BW, Okay, that's a part of BW modeling. So we can directly perform those BW modeling from here itself. So we'll be covering this also, in depth of this one also. See, all these are the HANA optimized info cubes, HANA optimized DS4s from BW server. So this is the new option given by SAP in the latest HANA Studio, the latest support pack of SAP HANA Studio. See, BW modeling. So once the modeling is done, then we can consume these information models, attribute views, analytical views, calculation views in SAP BW 4.0, 4.1 reporting tools. This is HANA as a data mart. So up to support pack 2, what is the product strategy of SAP HANA? SAP HANA can be utilized as one of the solutions for the big data. So whenever the client is using SAP HANA as data mart, 3 stages: data provisioning, loading the data from different source system to SAP HANA; modeling; reporting using SAP BW 4.0, 4.1 reporting tools. Yeah, any questions, folks, in SAP HANA as a data mart? So you need to have a clear idea about the basics of SAP HANA, because as a BW consultant, you are responsible for modeling, you are responsible for some other activities related to direct database, HANA database. So unless until all these basic concepts are not clear, so it's very difficult to understand the complete BW with SAP HANA as an underlying database. Any questions on HANA as a data mart? So if someone asks what is SAP HANA as a data mart, so up to support pack 2, HANA supports only data mart functions. This is what HANA as a data mart means. Data provisioning, modeling, and reporting. Means one of the solutions for the big data. When SAP released HANA 1.0 Service Pack 3, the product strategy of HANA has been changed. Focus is HANA as an underlying database for BW. The project name is Project Orange. Now, up to support pack 2, HANA cannot be used as a database, underlying database for any application. No. From support pack 3, one HANA database can be used as a data mart. The same HANA database can be used as an underlying database for BW. You don't have to purchase 2 HANA databases. No, only one HANA database as a data mart, and the same HANA database, if your client is using BW, SAP BW, Business Information Warehouse, which is a MOLAP application, they can use SAP HANA as an underlying database for BW. So in order to use SAP HANA as an underlying database for BW, we require BW version 7.3, minimum service pack 5 or higher, and HANA 1.0 service pack 3. See, this is one HANA database. So in one HANA database, so we created a number of schemas. We can store the big data. Now, the client is using SAP BW in their landscape. SAP BW as EDW, Enterprise Data Warehousing Application. See, from support pack 3, what is the product strategy of SAP HANA? One HANA database can be used as a data mart. The same HANA database can be used as an underlying database for BW in order to accelerate the BW performance. HANA will accelerate BW query performance as well as ETL performance. So what are the advantages of BW with SAP HANA? We discussed in the demo session. In tomorrow's session also, that is the first concept. What are the advantages? Today, after completion of the introduction to SAP HANA, tomorrow we'll start, okay, BW, how HANA is added value for BW, how HANA is a complementary for BW, and other concepts of other basic concepts before moving on to SAP HANA Studio. Now, let me show you this in the system. So this is our HANA database. So we have so many schemas. We can create again thousands of tables in each schema. We can store our big data. If I am using same HANA as underlying data, now I can use same HANA as underlying database for BW. Yes, we are using. For this BW, the underlying database is SAP HANA. If you want to see what is the database associated with this BW application, system status, see, database is HDB, HANA SP8, the host name, instance number 07. See? And all the BW tables, whenever you are creating, okay, different objects in BW, HANA optimized info cube, HANA optimized DS4s, or info object corresponding surrogate ID tables, master ID tables, everything will be created in only one schema. Owner means schema here. So in this schema, all the tables, if you have like okay, 100,000 tables, 200,000 tables for this BW also, where all the tables will be created in only one schema, SAP BW4. In this schema, all the tables of BW will be created and the data is stored in these tables, all the data of BW. Only one schema. See how many tables we have. Let me test. So the fact table of this cube is, this HANA optimized info cube is, F for fact table, / business intelligence custom defined object. This is a fact table of this. So where this fact table of the cube is created in HANA database in this schema. It's a column store table. So from support pack 3, the complete product strategy has been changed. The customers who are using BW as a EDW, who are facing the reporting query performance issues, other issues, by using traditional databases with BW, they can use SAP HANA as underlying database for BW in order to accelerate the BW performance. Then after, even HANA, okay, not only HANA can be used as a data mart, the HANA can be used as underlying database for BW. Means the target group of this product has been increased. Before, only the clients who wants to use, who wants to implement the big data solution, they can use SAP HANA. But now the target group has been increased by adding the customers who, okay, who can use HANA, in order to accelerate the BW performance, in order to overcome whatever the problems, okay, query related problems, other ETL related problems they are facing with BW by using traditional database. So we'll see other product strategies. So first we'll see what exactly is this HANA appliance, what are the components that comes along with this HANA appliance. SAP HANA is a appliance with a combination of software and hardware, and there are number of components that comes along with SAP HANA appliance. So what is a SAP HANA? It's an appliance. With a combination of software and hardware. It's an appliance with a combination of software and hardware. And this appliance comes along with different components. So what are those components? In any HANA appliance, the main and the core component, you can say heart of SAP HANA, is SAP HANA IMCE. The main and core component in SAP HANA appliance is SAP HANA IMCE. IMCE stands for In-Memory Computing Engine. That is nothing but in-memory database. HANA IMCE, In-Memory Computing Engine. The current version is 1.0, service pack is 8. So in-memory computing engine is nothing but HANA in-memory database, the database instance. See, this is IMCE. See the green one? So this is HANA IMCE, in-memory computing engine. So install on SUSE Linux. HANA supports only one operating system, SUSE Linux Enterprise Server. So other details of this IMCE. Okay. Other component is SAP HANA Studio. What is SAP HANA Studio? It's a client tool. It's a client software. So once we install the SAP HANA IMCE or SAP HANA in-memory database, this is a client software. We can install on our local machines or local PCs or our workstations. Using this SAP HANA Studio, we can connect to IMCE. So HANA developers, HANA administrators, okay, HANA BW consultants, they will use this SAP HANA Studio to connect to IMCE in order to perform their roles and responsibilities in the project. The second component is, this is SAP HANA Studio. See, this is a client component. See, I removed that HANA IMCE. See, it's only client tool. Now I can add IMCE here. You can add a number of IMCEs here. System means HANA IMCE. So this is another tool comes along with HANA appliance. Like this, the tools to connect to reporting tools like HANA IMC, JDBC, HANA ODBC, different components. So basically, how many components the HANA appliance consists of? Okay, how many components, with how many components this HANA appliance comes along with? It depends upon what type of edition we are purchasing from the certified vendors. So basically, HANA appliance is available in 3 editions. One is platform edition, second one is enterprise edition, third one is extended enterprise edition. So platform edition is a basic edition. Platform edition is for customers who already have license for SAP Business Object Data Services. Suppose a client, they already have a licensed version of Business Object Data Services 4.0, 4.1 or 4.2. In that case, they don't need any real-time replication method. They can go for platform edition. In platform edition, these are the following subcomponents. First one is HANA database, HANA IMC. Second, SAP HANA Studio. This is SAP HANA Studio. Then SAP HANA client tools. Okay, client tools to connect to reporting tools like IMC, ODBO, IMC, JDBC. Because different reporting tools in SAP BW 4.0 will connect to SAP HANA using different drivers. But most of the reporting tool will connect to SAP HANA using JDBC and ODBC drivers. And SAP HANA client tools, SAP HANA host agent. We'll cover SAP HANA host agent also. It's a small client tool. Okay, it's used by business users. Okay, manually inserting the data. And HANA information composer. HANA information composer is obsolete. The new component is SAP Lumira. So we will cover SAP Lumira also. So if you see the platform editions, we have very few components here. This is suitable for customers who already have SAP Business Object Data Services. If they want to load the data from different source systems, they can use Business Object Data Services. Let's say a client, they do not have any licensed version of Business Object Data Services and they require real-time replication methods also. In that case, they can go for Enterprise Edition. Enterprise Edition is for customers who do not have all necessary licenses for SAP Business Object Data Services. The following are the subcomponents: SAP HANA Database, SAP HANA Studio, Client, Host Agent, SAP Lumira, and they will get SLT also. See, these are the components we required in order to implement SLT, a real-time replication method, which is also known as trigger-based replication. So what are those components we required? SLT replication add-on, SLT replication server. And the client, in this edition, the client will also get SAP Business Object Data Services, which is an ETL tool of SAP. See, these are Business Object Data Services. Third one is Extended Enterprise Edition. Is for customers who wants to use the full potential of all available features. The following are the subcomponents. So we'll get all the components in Enterprise Edition plus Sybase replication server. There is one more real-time replication method, which is also known as log-based replication or Sybase replication method. In order to implement the Sybase replication method, these are the components required: Sybase Adaptive Server Enterprise ASE, Sybase Replication Server, Sybase Replication Server Agent, and SAP HANA Load Controller. So in SAP HANA is available how many components this HANA appliance consists of. It depends upon what type of edition the client is purchasing. Platform edition, Enterprise edition. The components in HANA appliance, the number of components in HANA appliance depends upon the edition of HANA, which edition, like platform, enterprise, and extended enterprise. So if you look at the HANA speed, so I was showing one of the POC result. So when we are executing a complex query on 460 billion records, time is only 13 seconds. Why SAP HANA is very faster? Why it's a super duper fast? So first one is, well, SAP HANA is a in-memory database. Using in-memory database, in-memory analytics is possible. And this is not only the reason. There are so many other reasons also. There are so many other factors which improves HANA speed. So in the sense, HANA can fully leverage new hardware technology innovations, new software technology innovations, which makes HANA super duper fast, apart from in-memory capabilities. So what is SAP HANA? It's an appliance with a combination of software and hardware. And it can fully leverage new hardware technology innovations. And it can fully leverage new software technology innovations, which makes HANA super duper fast, apart from in-memory capabilities. Now let's see what are the new hardware technology innovations the HANA can fully leverage, which makes HANA super duper fast. First we'll start with hardware technology innovations. So these are the hardware technology innovations. These are the software technology innovations that HANA can fully leverage, which makes HANA super duper fast. First, hardware technology innovations. So what type of hardware is supported by HANA, which is one of the main factors for the speed of SAP HANA. Okay, in SAP HANA, we can have multi-core CPUs. Again, 10 cores in each CPU. Multi-CPU boards. Again, 8 CPUs in each board. Multi-server boards into boards. Massive memory setups. Starting from 2 terabytes, we can go for hundreds of terabytes of RAM. Thousands of cores we can have. Look at this hardware configurations. What type of new hardware technology innovation supported by SAP HANA? Multi-core CPUs. 10 cores in each CPU. Multi-CPU boards. Again, in each board, 8 CPU. Again, in each CPU, multi-cores. Multi-server board into board. Massive memory setups. So hundreds of terabytes of RAM and thousands of cores. That is the reason, in order to install SAP HANA appliance, because HANA can fully leverage new hardware technology innovations, what type of Intel processor HANA supports? HANA supports very high-end Intel processors, because very high-end Intel processors only supports these type of hardware technology innovations, not like regular Intel processors. So what are those high-end Intel processors that can be used in SAP HANA, which are capable of supporting these type of hardware technology innovations? There are 2 Intel processors. One is Intel Nehalem, second one is Intel Westmere. So if you look at this product availability matrix from different vendors, so you can see the CPU, Nehalem, Westmere, Nehalem CPU. So why we cannot use regular processors of Intel? Because regular processors cannot support these type of hardware technology innovations. Now coming to software technology innovations. In software technology innovations, one of the biggest strengths of SAP HANA is SAP HANA supports 2 types of storage mechanism. In SAP HANA, we have 2 types of tables. One is row-based storage, second one is column-based storage. Second one is column-based storage. See, row based and column based. Now you can see a significant difference in the icons of these two tables. So I'm opening the definition of this table. What type of storage? This is a row store table. What type of table it is? It's a column store table. In row store table, the data will be stored in the form of rows and the data will be retrieved in the form of rows, like traditional databases. In traditional databases, how the data will be stored in the form of rows. We'll see more about row and column based table in our course. But this is only introduction class. Just I'm giving the overview of SAP HANA. Okay. Again, hardware technology innovations and the row store, column store. Okay, we'll see in depth of this in HANA modeling. Okay, which will be part of this course before moving on to BW in part 1. In row based tables, the data will be stored in the form of rows. The data will be retrieved in the form of rows, like traditional databases. But here also the same concept, but complete data resides in the main memory. The row based tables also resides in the main memory. But how the row based tables will operate, same as traditional databases. In row based tables, the data will be stored in the form of rows and the data will be retrieved in the form of rows. Now the question is, why SAP has given row based tables in SAP HANA? What is the purpose of row based storage? We discussed HANA product strategy up to support pack 3 only, right? In later support packs, so we are currently in support pack 8. See, later support pack 4, support pack 5, support pack 6, support pack 7, support pack 8. From support pack 6, HANA can be used as a, up to support pack 3, HANA can be used as a underlying database for BW and HANA as a data mart. But when SAP released later support packs, in later support packs, HANA can be used as an underlying database for SAP ECC, ERP central components, where we have financial applications, logistics applications, HRMS applications. What is SAP ECC? It's a transactional system. HANA can be used as an underlying database for SAP CRM. What is SAP CRM? It's a transactional system. In HANA 2.0, so currently we are in HANA 1.0 service pack 8. In HANA 2.0, one HANA database. One HANA database can be used as an underlying database for the entire applications in the system landscape. The systems can be SAP or non-SAP. Let's say one client is using one PeopleSoft application. They are using one database for this application. What is PeopleSoft? PeopleSoft Financials is a transactional system, a ERP system. SAP ERP, SAP Business Suite applications like ECC, CRM. The client is using these systems. They have different databases. So the client is giving the checks for different database vendors. But from HANA 2.0, one HANA database can be used as underlying database for all these applications in the system landscape. That is 2.0. But still we are not in 2.0. In HANA 1.0 Service Pack 8. Up to Service Pack 8, it supports HANA as underlying database for SAP ECC, SAP CRM. But what is SAP ECC? What is SAP CRM? These are OLTP systems. These are OLTP systems. Whenever I am using SAP HANA as underlying database for OLTP system, what type of tables we required? What type of tables are efficient for transactional processing? Row-based tables. So row-based tables are efficient for transactional processing. So whenever we are using HANA as underlying database for a OLTP system, what type of tables are efficient for transactional processing? Row-based tables. Suppose I am processing a sale order. I created the sale order application. Once I saved, if the database table associated with this sale order application in underlying database is a row-based, so it's faster way to insert the data in the row-based tables. Basically, the row-based mechanism is efficient for transactional processing. On the other hand, SAP HANA support column-based table also. What is column-based table? In column-based table, the data will be stored in the form of columns. The data will be retrieved in the form of columns. See, in column-based table, the data will be stored in the form of columns. The data will be retrieved in the form of columns. So whenever we are storing the data in a column-based table in SAP HANA, for column-based tables, column layout supports sequential memory access. We'll see all these details in our modeling sessions. A simple aggregate can be processed in one linear scan. Suppose if I need aggregate of amount, here the system has to scan 4 records. Here only one column. And massive parallel processing possible per column as well. So these are the features, extra features available for column-based tables. Whenever we are storing the data in column-based tables, it's highly optimized for reporting. The column-based tables are highly optimized for reporting. Whatever the data you are storing in SAP HANA for the reporting purpose, always will store the data in column-based approach. Because column-based tables are highly efficient for reporting. Whatever the data you are storing in SAP HANA for reporting purpose, always will use the column-based tables. Suppose I am using a BW application on top of SAP HANA. What is BW application? It's not a OLTP application. It's the OLAP application. So whatever the BW data I'm storing in SAP HANA, I require the data for the reporting. So what type of tables are efficient to store the data which is required for reporting? Column-based tables. Whenever you create any HANA optimized InfoCube, HANA optimized DSO in BW system, the system will create all column-based tables only in SAP HANA, because from BW we don't require the data. Okay, BW is a OLAP application. That's not a transactional system. So whatever the data which is required for the reporting will store in SAP HANA using column-based tables. The fact table of that cube. So what type of table it is? It's a column store table. You name any table in this schema, there is a column store table. Not only in this table. Suppose I required, okay, all controlling data for the reporting. So I will be storing the data in column-based tables only. So whatever the data we are storing in SAP HANA, which is required for the reporting, we'll store in a column-based table. Because column-based tables are highly optimized for the reporting. There is one more advantage of using column-based tables. Second advantage is the data is highly compressible. The data is high compression in SAP HANA using column-based tables. What is the compression factor? Like if you have 1 terabyte of data in traditional database, approximately 100 GB. So some of the clients who upgraded their database BW from traditional database to HANA database. The customer testimonials. If you look at the testimonials of these customers, you can see every customer, okay, what is the database size is reduced after upgrading to SAP HANA. So in traditional database, 1.5 terabyte of data. Once this client is upgraded to SAP HANA, all the BW data will store in SAP HANA using column-based tables, which are highly optimized for reporting and highly compressible. After migrating the traditional database to HANA database, so DB size after migration is reduced by 80%. 80% of 1.5, that's it. So this customer, this client, the total in a traditional database, 4.3 terabyte of data, BW database size. After migrating to SAP HANA, the BW system after upgrading to SAP HANA, because average compression factor column-based tables, the data is highly compressible using column-based tables. Partitioning. Now in SAP HANA, so what type of hardware technology innovation it supports? So hundreds of terabytes of RAM, thousands of cores. We can take the advantage of these many cores to speed up our query retrieval process. How? In SAP HANA, the data gets spread over all available cores. Suppose we have a table that is called partitioning concept. Table partitioning, okay, the data partitioning. The advantage of data partitioning is query retrieval process is very faster. Query speed is very faster. How? The data gets spread out all available cores, and all these cores process parallelly for faster retrieval of the data. In case one core is also failed, we don't have any impact on data retrieval process, because the responsibility which is allocated for the blade will automatically switch to some standby blades. Okay, so there are some standby blades because we have thousands of blades, and in case one blade is failed, automatically the responsibility which is allocated for the blade will switch to a active standby blade. So failure, individual blades may fail without causing the problems also. Now you don't have to worry about the aggregation. You can load very detailed level of data from any source system to SAP HANA. The data at document level, the data at line item level, very detailed level of operational data, means transactional data. Because HANA can accommodate very high volume of data. Really you don't have to worry about the aggregation. In a traditional analytics, we are very concerned about the aggregating the data, because if you don't have proper aggregation, the query retrieval process is very slow. No aggregations are required here. Now you can easily understand HANA definition. So what is SAP HANA? Is a technology, a big data technology, which allows the processing of huge quantity of the data. It includes real-time data also. Now we know what is real-time data. Huge quantity of real-time data in the main memory of the server. What is main memory? RAM. It processes complete stores the complete data in the main memory. It processes the data in the main memory itself. What type of data? Very huge quantity of data. That to real-time data. Data at document level, the data at line item level, to provide the real-time results from the transactions. Now we have seen, okay, what type of new software technology innovations that HANA can fully leverage, what type of new hardware technology innovations that HANA can fully leverage. Now I want to see one POC result so that I have some idea what is the speed of SAP HANA. This is an old POC. 70 retailers, they combined 460 billion records together, 50 terabytes of data. A complex query with complex calculations tested. Before it was taking 77 minutes without SAP HANA, using traditional databases, traditional tools. With SAP HANA, 13 seconds. And some average queries tested without much complex calculations, with average calculations, 0.04 seconds analysis response time on any device, anywhere, anytime. Recently, as I explained just now, NASA is also conducted one POC on using petabytes of data with the high end of HANA appliance. So the results are coming back in seconds. So let me show you one Gartner research. So in-memory computing, what is the purpose of an in-memory database? Conventional database disk read is 5 milliseconds. Now, by 2012, 70% of global 1,000 organizations will load the detailed data into memory as a primary method to optimize the BA application. This is a report from Gartner. I will go back to this slide. Okay, a company is using traditional databases, traditional tools. Though they are not having very high volume of data, even they don't have any big data, for example. Still, using the traditional databases, traditional tools, they have so many problems related to query performance, other reporting problem. What is the best method to optimize their BA application is? Just go for in-memory analytics. Just go for in-memory analytics. So load the complete data in a in-memory database like SAP HANA Greenplum, then start reporting from in-memory database. All the problems the companies were facing before related to query performance, blah, 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 we don't have anymore. Because in-memory analytics is very faster when comparing with traditional analytics. So not only the companies who are facing the problems with the big data challenges, big data consequences, they are going to use SAP HANA. The companies, okay, having the problems with reporting, so query performance related issues or any other issues, though they don't have the big data. So these type of companies also can use in-memory database, okay, in order to generate in-memory analytics, which is very faster. That is one of the best method to optimize the BA applications. See, this is a report. What is the best method to optimize the BA application? Load the detailed data into memory. That's it. Load the data to memory in memory database. Start reporting. Well, there are some certified vendors for this SAP HANA. Who are the certified hardware partners with SAP? From where a client can purchase this HANA appliance. IBM, HP, Cisco, Fujitsu, Dell, NEC, Hitachi, all these are the certified hardware partners. And from these hardware partners, this is the product availability matrix. Now you can see from the vendor name and product availability matrix, memory, file system. So we'll see the file system, what type of file system supported by HANA, operating system and all in our next session. Well, so we can have hundreds of terabytes of main memory in RAM. Okay, we can have very high-end processors in SAP HANA. So you don't have to go for a high-end HANA appliance unnecessarily. It depends upon your data storage needs. For what purpose you want to use SAP HANA? Then you can go for HANA appliance, the size of the HANA appliance. So this is one of the biggest challenges. Suppose whenever you are approaching a client as a HANA subject matter expert, suppose you are working for a big 5 consulting companies, they send you to a client side. The client said, okay, these are our requirements and suggest as HANA size. So how to give the suggestion to the client HANA size? Okay, which size of HANA appliance they have to go for. So those type of projects related issues also we'll talk. Okay, we'll discuss in our course. So basically the HANA appliance is available in t-shirt size. Extra small is the smallest one. Okay, so you can see the configuration. 2x8 core Intel Nehalem. So this is the memory and all. So uncompressed data, and this is the pricing. Now the pricing, okay, depends upon the sales executives, salesperson. The price will differ, but now the price is reduced by SAP. Okay, and different types of deals are available if they are going for different products of SAP. So this is very old pricing. So the second one is small t-shirt. So these are the requirement. These are the configuration. 2x8 core Intel Nehalem. Okay, the memory requirements, what type of log volume, data volume we'll see in HANA architecture. So we'll see all this, what exactly this configuration we'll see in HANA architecture. Then it makes sense. Then medium, large, and extra large. Extra large, you can specify how much terabyte of memory you require, 50, 100. So HANA appliance is available in t-shirt size. So once we have HANA appliance, you can use HANA as a data mart. You can use HANA as an underlying database for BW. You can use HANA as an underlying database for ECC, CRM. So how you want to use? You can use this HANA appliance. Very good. There is a question from a gentleman. What type of coding will be using in SAP HANA? So I will go through one by one. So SAP HANA is a database, in-memory database. In any database, what is the programming language we'll use? SQL, structured query language. Okay. Now I'm using business object data services to load the data from different source system to SAP HANA. To load the data to HANA tables. In that case, for ETL, whatever the scripting language is supports by BODS, so those are specific to the BODS. Suppose I can use different types of transforms in BODS, like platform transforms, data integrator transforms, okay, data quality transform, text data processing transform. Apart from that, I can use okay, scripting language. So the scripting related to BODS to load the data to SAP HANA. Now, we can use SAP HANA for application development also. So application development using ABAP, application development using Java. So these are the external programming languages. But the core programming language supported by SAP HANA is SQL. Like this, SAP HANA architecture is very vast. If you look at the architecture of SAP HANA, there are so many tools, there are so many technologies will interact with SAP HANA. Suppose just now I was explaining one scenario, loading the data using business object data services. So whatever the transform supported here. Now I'm loading the data using SLT, real-time data. But in real-time replication also it supports some transformations. We can write the transformation here using ABAP coding. So application BW, HANA we are using underlying database for BW. Now we are directly loading the data to BW transformations. It supports ABAP programming language. So the basic programming language supported by SAP HANA is SQL, structured query language. Apart from that, HANA can understand MDX, multidimensional expression, and what tool you are using with SAP HANA. So that tool required any coding, the tool specific programming language. See, we can use SAP HANA application development using ABAP. See, ABAP profiling, ABAP. See, we can use Java, application development using Java. Yeah, second question. Very good. So SQL is supported for column-based tables also. SQL is supported for column-based tables also. So quickly I will recap what we discussed today. Then, I'm open for the questions. So today we started with introduction to SAP HANA, because whenever we are learning BW with SAP HANA as underlying database, so as explained in the demo session also, this course is divided into 3 parts. In part 1, we are learning complete SAP HANA, up to what extent we require SAP HANA, to work BW with HANA as underlying database. Second part is complete BW. Third part is complete new features of BW 7.3 Service Pack 5 to BW 7.5 Service Pack 5 HANA as underlying database. This is a course syllabus. So part 1. So part 1 is complete SAP HANA, up to what extent we require SAP HANA. Part 2 is BW modeling, extractions, reporting using BEX reporting tools. Part 3 is complete new enhancements, BW 7.3 and 7.4 with SAP HANA, like consuming HANA models in BW, virtual providers, transient providers, all these, we'll send anyways this course content, and these are the projects we'll be covering, as well as for every session we'll be having corresponding case study and assignments. So first we started with part 1. So in part 1, introduction to SAP HANA. A brief introduction to SAP HANA. What is SAP HANA? What is the product strategy of SAP HANA? What is the necessity of a high performance analytical appliance like SAP HANA to an enterprise? What type of software technology innovations and hardware technology innovations that HANA can fully leverage, which makes HANA super duper fast? In which editions the HANA is available? What are the different editions in which the HANA is available? And who are the certified hardware partners? And what are the sizes in which HANA appliance is available? Very basic introduction. Well, so first, the necessity of SAP HANA. Why an enterprise required a in-memory database like SAP HANA? Because there are so many traditional databases, traditional tools available in the market. So first we'll see what is the necessity of a high-performance analytical appliance for an enterprise. First one is information explosion. So as a result of information explosion, so these are the challenges faced by an enterprise. These are the consequences. So whenever a company, an enterprise managing such a high volume of data or big data using traditional databases, it's a very cost effective of large data volume, current and incomplete solution. Okay, getting immediate answers to any business question, the query execution is very longer, because in traditional databases, using traditional databases, traditional analytics is possible. In a traditional analytics, in any traditional database, the complete data resides in the hard drive. Whenever we require the data for the reporting, so the processor has to read the data from a mechanical device like hard drive by performing disk IOs, which require significant amount of time, which are major bottlenecks. But in a in-memory database like SAP HANA, the primary persistence of the data is not a hard drive. The complete data resides in the RAM itself. And from RAM, directly the data is available for the reporting. So in-memory analytics are possible using any in-memory database like SAP HANA, Greenplum. So whatever the challenges and consequences the enterprises are facing as a result of information explosion, we can overcome all those challenges and consequences with SAP HANA. So the reality with SAP HANA, groundbreaking in-memory innovations, highly scalable, highly flexible, because from any source system, we can load the data to SAP HANA. Even we can replicate the data in the real-time mode, which is one of the biggest challenge, getting the real-time data from a source system in a traditional databases. And HANA not only supports in-memory capabilities, apart from in-memory capabilities, just now we have seen what are the new software technology innovations and hardware technology innovations that HANA can fully leverage, which makes HANA super duper fast. So 3,600 times faster analytics when comparing with traditional analytics. If you look at the history of SAP HANA, SAP released SAP HANA in 2010. First public release is HANA 1.0 Service Pack 0. Up to Service Pack 2, HANA can be used as a data mart function. What exactly SAP HANA as a data mart? Before going to HANA as a data mart, we have to understand what is a big data. So what is a big data? Big data refers to data sets that exceeds the ability of commonly used tools. While no formal definition based on size exists, so big data starts with terabytes, petabytes, and even exabytes. First, SAP released SAP HANA to one of the solutions for the big data. So whenever a client is using SAP HANA as one of the solutions for the big data, or SAP HANA as a data mart, in that project we have 3 stages. First stage is loading the data from different source system to SAP HANA, data provisioning. So the data provisioning using business object data services, ETL based approach, flat files, real-time replication, real-time data provisioning using SLT, Sybase replication, different data provisioning methods given by SAP as per the needs of the customer. Once the data has been loaded to HANA database tables, then we'll use a tool called SAP HANA Studio to design the modeling objects, to design the information models in order to facilitate the reporting requirements. Once the modeling is done, we can consume these information models in SAP BW 4.0, 4.1. On top of SAP HANA, only certified reporting tools are SAP Business Objects, Business Intelligence Tools, 4.1 and 4.0. So we have Web Intelligence for ad hoc reporting in Business Objects BI, SAP BOBI, Dashboard Reports, reports with visualization, Crystal Reports for Enterprise, for highly formatted reports. So these 3 tools required the universe on top of SAP HANA, semantic layer. So we'll design the semantic layer using information design tool. Then business objects analysis, business object explorer, Crystal Reports 2013, 2011. So these are the different reporting tools, okay, different for different needs of a customer in BOBA 4.0 and 4.1. So when SAP released HANA 1.0 Service Pack 3, the product strategy has been changed. From Support Pack 3 onwards, not only we can use HANA as a data mart, we can use HANA as underlying database for BW also. By using SAP HANA as underlying database for BW, HANA accelerates the BW performance in reporting perspective as well as in ETL perspective. So tomorrow we'll see what are the advantages of using HANA as underlying database for BW. How HANA is going to be added value for BW. So in order to use HANA as underlying database for BW, we require BW 7.3, minimum service pack 5, HANA 1.0, service pack 3. So what exactly is SAP HANA? SAP HANA is an appliance with a combination of hardware and software. And there are different components, okay, comes along with this HANA appliance. The main and important component in SAP HANA appliance, you can say heart of SAP HANA, is HANA IMCE, in-memory computing engine. That is nothing but HANA in-memory database. And SAP HANA Studio, okay, SAP HANA Host Agent, SAP Lumira, the different components. So how many components a HANA appliance consists of? It depends upon what is the edition of SAP HANA. So there are three editions in which HANA appliance is available. One is Platform Edition, which is a basic one. So this edition is suitable for customers who already have a valid licenses for business object data services. The following are the subcomponents. You can see HANA IMCE, Studio, Client Components, Host Agent, SAP Lumira. Enterprise Edition is for customers who do not already have all necessary licenses for SAP Business Object Data Services. Following are the subcomponent. So here we'll get all the components from Platform Edition plus components to implement SLT and Business Object Data Services, which is an ETL tool, SAP proprietary ETL tool. And third one is Enterprise Extended Edition, is for customers who wants to use all the facilities of SAP HANA, including site-based application server. So SAP HANA is an appliance which can fully leverage new hardware technology innovations and new software technology innovations. So what are the new hardware technology innovations that HANA can fully leverage, which makes HANA super duper fast? HANA supports multi-core CPUs, 10 cores in each CPU, multi-CPU boards, 8 CPUs again in each board, multi-server boards into boards, and we can have massive memory setups. So terabytes of RAM, hundreds of terabytes of RAM. So we'll see again hardware technology innovations, software technology innovations one more time in SAP HANA architecture. Then coming to software technology innovations, row-based and column store. SAP HANA supports two types of tables, row-based tables, which are efficient for transactional processing. Because later support packs, HANA support as underlying database for SAP ECC, SAP CRM, which are SAP Business Suite applications. These are basically OLTP systems. So whenever we are using SAP HANA as underlying database for OLTP system, row-based tables are efficient. For transactional processing, row-based tables are efficient. In row-based tables, the data will be stored in the form of rows and retrieved in the form of rows. Same like traditional databases. Only the difference here is row-based tables also resides in the main memory. On the other hand, SAP HANA also supports column-based tables. In column-based tables, the data will be stored in the form of columns, retrieved in the form of columns. In the modeling, we'll see more details about these storage approaches. So for column-based tables, column layout supports sequential memory access. One aggregate can be processed in one linear scan, very faster. Suppose if I need amount to be aggregated for each customer, here I need 4 rows to be scanned. But here only one column will be one linear scan. We can do the complete aggregation. And for other, okay, these other options are possible for massive parallel processing, okay, possible for column-based tables. So column-based tables are highly optimized for reporting. And one more advantage of column-based tables are the data is highly compressible. That is the reason whenever we are storing any data in SAP HANA, which is used for reporting purpose, always will store in column-based tables. So we can take the advantage of compression as well as query speed. And partitioning. So the data gets spread out all available cores. We'll see this concept again in HANA architecture. What is data distribution? And the cores can process parallelly for faster retrieval of the data. In case one core is also failed, we have thousands of cores. There are some cores which are standby cores, so the responsibility will automatically switch to active available stand core so that we don't have any impact in the data retrieval process in case a core is also failed. So this is one POC result which we discussed, and these are the certified hardware partners for SAP HANA like IBM, HP, Cisco, Fujitsu, Dell, NEC, Hitachi. From these certified hardware vendors, and these are the product availability matrix. In HANA architecture, we will be touch base with this product availability matrix. And HANA appliance is available in t-shirt size, starting with extra small, small, medium, large, and extra large. Now it's your turn, folks. Yes. How much can you make hourly? Okay, once we have job. Always the billing depends upon your profile. Not only in SAP HANA, in any other tools and technologies also, the billing depends upon your profile. So HANA is available in the market 2010 November. Okay, hardly you can show not more than 3 years of experience in SAP HANA. Again, what type of experience you are claiming in SAP HANA? HANA as a data mart, HANA as a, you are already BW consultant, and you want to go for BW HANA, you want to focus only BW HANA. Suppose you are claiming 3 years of HANA experience. Before that, you are claiming some business objects experience or some other data warehousing experience. Profile with 5 plus, 7 plus years of experience, like intermediate level consultant. So you can expect at least $120 to $130 an hour. It's not a senior profile. Again, the billing depends upon how many layers we have from client to. Suppose this is a client. For this client, there is a primary vendor. So who is the primary vendor? The party who will supply the resource to the client. So you approach to this position directly through primary vendor. Suppose you are working on car to car basis, means you have your own corporation. So this is the resource corporation. So client release, for example, $150 an hour. Now you have only one layer. So this guy will take his piece of bread. Then like 10, whatever the margin, the remaining bill will come to you. So very good billing, because you have only one layer. Suppose you are approaching this position not via a primary vendor. So some other layer, some other vendor applied to a primary vendor. Again, you are working in Bay Area, in West Coast. The billing is a little bit high because Bay Area is a bit expensive. If you are working for oil and gas clients, the pay rates, the billings are very good. So when talking about an average billing for intermediate level consultant, you can get this, but provided you have to show some other data warehousing related experience, some other business service experience. For high profile, HANA subject matter expert, HANA solution architects, with 10 plus, 14 plus years of data warehousing experience in BW, in business objects, including last 2.5 years, 3 years, you are working with HANA projects. For those type of profiles, you can expect like 140, 150 also. See, this is a SAP HANA solution architect, a senior level position. SAP HANA molder, a intermediate level position. See what type of skill set there. You are a solution architect. You need to have the complete idea about SAP HANA. Because SAP HANA is not a, we can use SAP HANA in different prospects. If you look at the HANA product strategy, how we can use SAP HANA. Now if you look at this diagram, HANA can be used as a data mart. Whenever a client is using SAP HANA as a data mart, what type of skill set the client will expect from the resource? Data provisioning skills, modeling skills, and reporting skills. So when a client is using SAP HANA as a data mart, so go to this position, SAP HANA Solution Architect. Skill set, expert knowledge of full software development life cycle using SAP HANA. Means SAP HANA as a data mart, see using business object data services, loading the data, SLT, real-time replication, reporting using business object 4.1 reporting tools, data provisioning, okay, reporting using various types of reporting tools, complete full life cycle of SAP HANA. How HANA can be used as a data mart, how HANA can be used as an underlying database for BW, because this is a very senior level position. HANA molder, this is not that much of senior level position, a intermediate level position. So they are asking for one project experience in SAP HANA. So 5 years in SAP BW, BW, because the client is using SAP BW with SAP HANA. So BW skills are mandatory here because the client is implementing this project. HANA can be used as a data mart. HANA can be used as a application development using Java, ABAP. Okay, HANA can be used for only reporting purpose, loading the data to SAP HANA, modeling and reporting and analytics using BOBA 4.0. Okay, SAP HANA as an accelerator, BW and HANA, Cloud and HANA, Business One Analytics and HANA. These are the different ways how HANA can be utilized. What type of project the client is implementing, it depends upon that project. Okay, the client will expect the skills from the resource. See, whenever we are working BW with SAP HANA, BW modeling is compulsory because we'll consume HANA information models in BW by creating transient providers, composite providers. Okay, unless until if we don't have complete idea about attribute views, analytical views, we cannot work with BW with SAP HANA. So HANA architect is again senior level position. You need to have complete idea about SAP HANA complete landscape. So the client is using SAP HANA as a data mart, BW with SAP HANA, HANA Live. SAP HANA consultant. This is not a very senior level position. This is an intermediate level position. And the client is using SAP HANA as a data mart. This project is SAP HANA as a data mart. So they need the data to be extracted from SAP ECC, modeling, okay, reporting, So how to extract the data from different databases, Oracle, SQL Server, DB2 to SAP HANA. Because the client is using SAP HANA as a data mart. So whenever the client is using SAP HANA as a data mart, what type of skill set the client will expect from the resource? See, HANA as a data mart. Modeling skills means data warehousing skills. So how we'll design the information models? By following all data warehousing modeling principles. Star schema, extended, okay, snowflake schema, data provisioning, loading the data, modeling, reporting. This is complete nothing but your data warehousing project or big data project or HANA as a data mart. So HANA can be used as these many scenarios. So what type of project the client is implementing? So the main, as of now, we have so many projects, HANA as a data mart and BW and HANA. Okay. Suppose when you are learning BW and HANA, what part of HANA data mart you are missing? The part of HANA data mart you are missing is data provisioning, and anyways, here also modeling will cover, here also modeling will cover, and reporting using SAP BW. So in HANA as a data mart course or in SAP HANA course, we'll teach data provisioning in detail. Okay, this is a separate course again. So this is SAP HANA general, means SAP HANA data mart course. See, first introduction, look and feel of SAP HANA Studio, SAP HANA architecture. First we'll start with data provisioning. So whenever a client is using SAP HANA as a data mart, there are 3 stages in the project. So data provisioning. So we'll learn data provisioning using flat files, data provisioning using Business Object Data Services 4.2 in detail, see architecture, how to use different types of transforms, how to write the scripts, everything. Then SLT, then in-depth of modeling, in-depth of reporting, then user management. Here we'll learn, okay, some concepts of BW and HANA, not all, just an overview, okay, how BW HANA is added value, okay, what is HANA optimized info cubes, HANA optimized DSOs, some concepts. But in BW and HANA, 3 parts. Up to what extent we required SAP HANA, okay, and including in depth of modeling, then complete BW, then BW 7.3, 7.4 enhancements related to SAP HANA's underlying database. So the course which we are going to cover in this is this one, BW and HANA. Suppose you are a BW consultant, okay, you can explore from your side the BW related concepts with SAP HANA. Then you can go for HANA data mart, where you are learning data provisioning. Now you are not a BW consultant, so first you can go for BW and HANA, and we can provide, okay, whatever the charges, we can provide complete videos for HANA data mart also. That way also you can talk to the management people. So if you want to, okay, if you are from non-BW background, if you want to target both the types of jobs, HANA as a data mart jobs, BW with SAP HANA jobs also. Even in fact, for those type of jobs, the billing is very high. So the client wants to need a one resource who can work on data provisioning part, modeling part, reporting with BO as well as BW with SAP HANA. Yes, SAP, whenever we are using SAP HANA to store the big data, HANA as a data mart, It's nothing but a big data project. Well, if you don't have SAP experience and you are, suppose after completion of this course, you certified in SAP HANA. The question from Omar, how to get a contract, okay, without SAP experience after getting a certification? Well, whenever you are looking for contracts or if you want to crack a good contract or job, if you are applying, okay, I don't have any experience and just I am certified, even no vendor is going to call for the interview. Just we have to fabricate the resume. So we will prepare your resume, we'll assist you how to prepare the resume. And if you want to market your resume also, we'll market and we'll take care of the proxy as well. Okay. So we'll take care of that. Once you are in the project also, we'll take care of providing the assistance for by the time you get settled in the project. So these are our post-training process. So resume guidance, certification guidance, proxy, okay, support after once you are in the project also. So that's the way, only the way how to get into, okay, that is everyone does the same thing. Suppose if you say I don't have any experience, just I am a certified in SAP HANA, please provide me the job. If you prepare your resume like that, start marketing, even no vendor is going to call for the interview. Yes, there are so many clients who are using SAP HANA as a big data project. SAP HANA is one of the solutions for the big data. So this is nothing but HANA big data project. This is a big data project. So whenever a client is using SAP HANA as a big data, in that project we have 3 stages. Data provisioning. See, the client is using SLT, the client is expecting from the resource, okay, SLT, BODS, then modeling, then reporting using SAP BW 4.1. Again, what type of reporting tools the client is expecting from a resource? Web Intelligence, Crystal Reports, Dashboard Design, Business Object Explorer, Information Design Tool. So this is a HANA Big Data project. So whenever a client is implementing HANA as a big data, in that project, data provisioning, modeling, and reporting. Reporting using SAP BW 4.0, 4.1 reporting tools. So what are the tools we have in BA 4.0 and 4.1? Web Intelligence, Dashboard Design, Crystal Reports, Business Object Explorer. You can see the requirement. This is a big data project. Nowhere they specified the BW. This is a complete big data project. So this Web Intelligence, Crystal Reports, Dashboard Design require the universe on top of SAP HANA. See, we'll design the universe using Information Design Tool. So what are the requirement I was showing? HANA as a data mode, big data project using SAP HANA. Yeah, any other questions, folks? Daniel, Dilesh, Muhammad, Omar, Ramya, Vanita, Vijay Kumar. Okay, tomorrow's our class agenda is how SAP released SAP HANA. Means SAP HANA is a synthesis of 3 products. We'll see what is BWA tomorrow. Okay, what is the persistence layer, some concepts of HANA, along with how HANA accelerates the BW performance. How HANA is a added value for BW. Then we'll start SAP HANA Studio. After completion of SAP HANA Studio, SAP HANA architecture in various prospects. Then we'll go for, okay, what exactly a data provisioning. Then we'll start modeling in SAP HANA. So after covering part 1, we'll move on to part 2, which is BW. So part 1 is mandatory before start understanding the BW modeling with SAP HANA. Yeah, that's all for the day, folks. Have a good night, everyone. See you guys tomorrow.